In Unit 6.1, we talked about law of sines, in which we can find the distance or an angle given another, in a triangle, given another set of angle and distances that pair up sine of A over the distance of A. However, what if we don't have any angles that pair up with sides? So here in 6.2, we are going to talk about law of cosines. So for here, in sines, we had to a side and the opposite angle pair up. But what if we didn't? What if we had an A, B, and C, but we didn't, let's say we know what angle B is, but we only know the distances to A and C. How can we find everything else? How can we find everything else? And that's where cosine comes in handy, the law of cosines. And our law of cosine basically says, what if we want, it basically says, I rewrite this, it says c squared, the side that we want to find, is equivalent to the sides that we don't have, a squared, that we already have, so a squared plus b squared, minus 2ab times the cosine of c, so the angle that we do have. So let's use that today to solve the other things. Let's say we have a triangle. We have triangle A, B, and C in this case is the one we're missing. We know this angle. This is 108. And let's say A here, this distance A is 9, so little a is 9, and B is 4.5. And they want us to find everything else. They want us to find angle A, angle B, and side of the distance C. Let me fix this 108, make it look better. So let's do that. Let's use the law of cosines. So here, first we can find C easily. So C squared equals A squared, so that is 9 squared, plus B squared, so 4.5 squared, minus 2 times AB, which is 9 times 4.5, times the cosine of C, so cosine C in our case is 108. So we put all that into a calculator and we crunch the numbers. C squared should be around 126.2804. If I square root that, my C value in this case is 11.24. So that is my C. To find A and B, we can use the law of cosines again, but I have a particular fondness for my sines, so I'm gonna just use my sines, law of sines. So we have our C value now, so I know that 11.24 over 108, so the sine of 108 must then equal, and I can find the other angles using this, so I can find angle B. So 4.5 over the sine of whatever B is. So then B is, if I rewrite this here, so sine of B equals 4.5 times sine of 108, divide that by 11.24, and then to find b, we just take the inverse of whatever this answer is. So first I'm going to find what that is. I got 0.375, so sine of b equals somewhere between 0.375, and then if I took the inverse of that, so b equals the inverse of 0.375. This gives me 22 degrees for my angle, so b is actually 22 degrees. So if I go back up here, 22 degrees, so this is 11.24, this is 22. Now I can use my triangle rule, so 180 minus 108 minus 11.24, and that will give me A, and A is 50 degrees. So angle A is 50 degrees. Let's do a word problem using this. So let's say we have a vertical water tower and it's on the side of a hill. So the hill in this water tower is slanting down like so. And the hill makes a 6-degree angle from the horizontal. What that means is from the ground or the horizontal ground, this would technically be 6 degrees. And then they want us to, they say the height of the tower is 120. So here, this would be the tower. Imagine this is a tower here. This height itself is 120. So this is 120. And find the length of the two guide wires that will be anchored, 75 feet uphill and downhill from the base of the tower. Okay, so so here, imagine there's a wire that's from here, this is 75. And then that creates a wire right there, and then this is 75. And then that creates a wire down there. And we need to find the length of the individual wires. So this wire here, and this wire here. So let's get to it. So we have two distances. We need to find the third distance. That's 6-degree angle. How can we use that 6-degree angle? Well, if we think about it, if I draw a parallel line to that 6-degree angle here, doesn't that make this also 6 degrees? This is 6. And this is then a right angle, so this entire angle here is actually 96 degrees. So that angle in particular is 96 degrees. And if I draw another parallel line, remember, I'm just going to make this blue where the tower is. This is where my tower is. From here to this, right here, isn't this supposed to be 90 degrees? But I'm only missing 6 degrees from that. So technically, this angle right there is 90 minus 6. So that is 84 degrees. I got a 84 degree and a 96 degree. So if I draw a representative of that angle here, this is 96 degree. I have 75 here. I have 120 here. Well, no, not 120. I'm sorry. So technically, yeah, kind of like 120. Yeah, I slanted it. And then this would be kind of, this is the 120 here. This would be 84. And then this would be 75. So those are the two triangles that I have using this. So let's find the longer one. So the red ones. So let's find the longer one. So here, my distance squared. So I'm gonna call this D1 and this is D2. So D1 squared must equal 75 squared plus 120 squared minus 2 times 75 times 120 times cosine of 96 degrees. Plug that all into my calculator, and I should get around 21,906.5. That means if I need to square root it, right, square root it, my first distance is 148.0 feet. Do the same thing for my second distance, my D2. Squared equals 75 squared plus 120 squared minus 2 times 75 times 120 times 84. This gives me 18,000, somewhere around 18,143.5 D2 squared. So we got a square root. Remember square root. So D of 2 equals about 134.7 feet.